Okay, Math 8, we're on to the last part of this section. So we're going to be looking at what types of solutions we have for different systems. And there are three main types, as you can see here. So looking at one solution first. Highlighter is coming in handy in order to point out the key features. So first off, we'll notice that the slope of the first line is 4. The slope of the second line is -2. And therefore, when there's a different steepness and a different slope, that means we're going to have lines that will intersect in one place. They will cross once and then they'll continue on forever and never cross again. So I'd like you to take a moment and to graph this in Desmos and make sure you can find the solution to the system by graphing. Once you've graphed it in Desmos, you should see something like this. So the solution is -1, -7. The next one, it says it here in bold, but just to point it out with highlighter, we have the first line having a slope of 1/5, the second line having a slope of 1/5. They have the same slope, but you'll notice the intercepts are different. We have 0 and we have 6 as the intercepts. So what will happen is the steepness will stay the same, but they start at different points, one starting at 0, one or crossing through 0, and another crossing through 6. So we know these are parallel lines, and therefore they will never intersect. So please take a moment and graph those in Desmos and see what you notice, and then write in the solution. And you'll notice the graph is parallel lines, as I mentioned, and therefore the solution is no solution. These will never cross. The last type of solution for a system is infinitely many. And you'll notice the second equation on here is not written in slope-intercept form. And the reason that is that we need to write it in slope-intercept form. So we want to get y by itself. In order to get rid of 3 times y, we need to undo 3 times y by dividing by 3 and dividing by 3. And you'll notice we get y equals x. Well, these are exactly the same line. If I had wrote the same line twice, it'd be very, very obvious, but we have to do one step to figure that out. So therefore, these are identical, and because they're identical, we're going to have the same line. So you could graph this one or just look. It's going to be the line on top of itself. So if you enter 3y equals 3x into Desmos right here, the bottom, it will result in the same line. The blue is being graphed on top of the red, and therefore the solution is infinitely many. We can use the infinity symbol shorthand, but we're meaning infinitely many. Now, what we're supposed to be able to do is to identify these without a graph. So you have to kind of imagine what it would look like without Desmos. But, today you could check with Desmos to see if you're correct when needed. But we're supposed to be able to do them without a graph. So here, we're looking at these lines, and you're noticing what type of lines would they be? Well, we have 4 as the slope and -1 as the y-intercept, and we have 4 as the slope and +2 as the y-intercept. So what do you think this would result in? What type of lines? Well, because they have the same slope and a different y-intercept, these are going to be parallel lines, and therefore there is no solution because these parallel lines will never cross. 3b, so we look at what we have. We have 2 slope. We have a -1 slope. Now the intercept's the same, 9 and 9, so think about what that would look like. Will these ever cross? Will these be infinitely many? What do you think? Well, these are different slopes, therefore different steepness means they will intersect once, and if you graph it on Desmos, you will get an answer of 0,9 because they have the same intercept because that's where they cross. 3c, think about what you probably should do first. If you don't isolate y on the second one, oftentimes the common mistake is people think the slope is 10 and the y-intercept is 8. But it's not because this is 2y, y is not isolated. So we need to isolate y first, getting rid of 2 times y by dividing by 2, dividing by 2, dividing by 2. And this line will become y equals 5x plus 4. And now hopefully you can see that these are exactly the same line. So therefore, if we graph them, it's one line on top of itself, and therefore it's infinitely many because this line will share all of the same points as the other line, and it goes on forever to infinity. So it has an infinite number of points in common. This last one is the most work because you'll notice both of these are not written in slope-intercept form. So we have to rewrite this one, isolating the y. Go ahead and please try it and then check how you did. Subtract 2x on both sides. You'll get 3y equals 6 minus 2x. Still got to get the y by itself. So divide by 3, divide by 3, divide by 3. And so this becomes y equals 2 minus 2/3 x. We also need to rewrite the second one. So on this one, once again, please try it first. Circle the y. We need to get rid of the 12x first. So it becomes 8y equals 56 minus 12x. Then we need to divide by 8 to get rid of the 8 times y. And then we can also simplify this 12 over 8 fraction. We can divide both of those by 4. So 56 divided by 8 becomes 7. 12 divided by 4 becomes 3. 8 divided by 4 becomes 2. And we have y equals 7 minus 3/2 x. You could switch these two terms and these two terms, but you don't have to. We just have to look at the slopes. So we have negative 2/3 and negative 3/2. These are not the same slope, even though they look similar, but they're not identical. Therefore, different slopes means there will be a solution. 6 comma negative 2 is the solution if you graph both of these in Desmos. And later on, you're going to learn how to find the solution 6 comma negative 2 without using Desmos. Go ahead and try the U-try, please. Figure out what type of solution this system would have. Okay, got to get this one by itself, so don't be tricked. Sometimes people will think, oh, this is a positive 3x, this is a negative 3x, different slopes. Well, not the case, because we have to do minus 3x to both sides, and we'll get y equals 1 minus 3x. So therefore, we have the same slope, negative 3, different intercepts. So if the steepness is the same, but the intercepts are different, that means we're going to have no solution. And there it is. We have a negative 3 slope, same steepness, but different y-intercepts, so they cross at different points.